So good morning to all. I'm Wen Xi, and today I'm going to present chapter 6 for physics, and for the task 6.1. The question is, if you could swim like Ant-Man for 2 minutes and dive in pure water, tell us what is the shape, color, arrangement, and movement of protons, neutrons, and electrons. First of all these protons, neutrons, and electrons are spherical, and protons and neutrons have the same diameters, but both protons and neutrons have larger size than electrons. Secondly, all three protons, neutrons, and electrons are colorless because they do not reflect visible light. Thirdly, both protons and neutrons make up the nucleus at the center of atom, whereas electrons are surrounding the atom. Lastly, both protons and neutrons do not move in the atom, while electrons only move when there is the presence of electricity. And moving to the second question. Take a deep breath. Assume the total weight of air intake is 5 grams with 78% nitrogen, 21% oxygen, 1% carbon dioxide. Then calculate how many molecules you breathe into your lung. So there are total 5 grams of air, so we have to find each percentage of 5 grams for each air. So for nitrogen, we will find the 78% of 5 grams, which is 3.9 grams, and for oxygen, we have to find the 21% of 5 grams, which is 1.05 grams. And for carbon dioxide, we have to find 1% of 5 grams, which is 0.05 grams. And secondly, we will find the relative atomic mass for each gases. And for nitrogen is 28 grams, for oxygen is 32 grams, and for carbon dioxide is 44 grams. And each relative atomic mass will represent 1 mole of gases, which is equals to the Avogadro numbers, which is 6.022 times 10 power of 23. And next, to find each gaseous molecule in 5 grams of air, we have to take the exact mass of each air to find their molecule. So for nitrogen is 8.39 times 10 power of 22 molecules. For oxygen is 1.98 times 10 power of 22 molecules. And for carbon dioxide is 6.84 times 10 power of 20 molecules. Finally, we sum up the total of molecules found, and the final answer is 1.04 times 10 power of 22 molecules. And moving to the third task, a helium occupies a balloon with volume of 2 liters at 20 degrees Celsius. Assume pressure constant and heat applied. The balloon expanded to 4 liters, and find the temperature inside the balloon. So since the pressure is constant, therefore we will apply the Charles' law, which is the V1 over T1 equals to V2 over T2. And for V1, it's we convert from the 2 liters, and finally we will get the 2000 cm cubed. And for V2, same also, convert from the 4 liters, and we convert it to 4000 cm cubed. And for the T1, it's given by the question, and we have to convert the degree Celsius into the Kelvin. So we have to sum up the 20 degrees Celsius with 273.15 Kelvin equals to 293.15 Kelvin. Then finally we will get the answer. For T2, it's equal to 586.3 Kelvin. And lastly, we have to convert back the Kelvin to the degree Celsius, which is the 586.3 Kelvin minus 273.15 Kelvin equals to 313.15 degrees Celsius. This is the final answer. And for the last question, find weight in kg for a nitrogen molecule, then find the speed of nitrogen air molecules at 900 degrees Celsius. So firstly, we have to let the weight of one nitrogen molecule equal to x. Then the weight of one nitrogen molecule will over the relative atomic mass of the nitrogen equals to the 1 mole over the Avogadro number, which is the 6.022 times 10 power of 23. And finally, we will find the weight of one nitrogen molecule is equal to 4.65 times 10 of power negative 23 gram, and we have to find the weight of the one nitrogen molecule into kg. So we divide the this number with 1000, therefore we will get 4.65 times 10 power of negative 26 kg. Then we substitute the value into this formula. 3 over 2 kT equals to 1 over 2 mv squared. Then finally we will get the v squared equals to 1,045,161.29, and finally we will get the speed of light equals to 1022.33 meter per second. That's all from me. Thank you.